loading and saving programs written in Atari Basic. So I guess when you use load and save, you kind of made it a little bit easier for it. I guess like it's already tokenized, so it doesn't have to retokenize it, but maybe it's not such a big deal. If you have an Atari Assembly editor cartridge, this part we don't really care about. We don't have an Atari Assembly cartridge. Object code listings are loaded into memory using the command load with the Atari assembler or bload with the MAX65 and are saved to disk using the command save or bsave. Source code programs must be loaded into memory and saved to disk while your assembler is active in its edit mode. But object code programs can be loaded and saved in two different ways. Okay. Let me put this back in this so it's a little easier to read. You can load and save object code programs while your assembler is active in its edit mode. You can also load and store object code programs using either the Atari or OSA Plus disk operating systems. I think we're in the OSA Plus disk operating system because when I restart, that's what I have. Right. To save an object code program using the Atari DOS menu, all you have to do is select menu option K, the binary load command. To save an object code program using the OSA Plus operating system, the correct format is, all right, let's try this. So I go back to DOS. So you can see here's DOS, right? FTE DOS XL, I think, is an updated version of this OSA Plus. And now I can do D2 colon save add numbers dot object 06 to 0608. So that worked. Alright, so there's object, where's the object code? foo.object. I probably typed that in wrong. Let me try it again. Because I don't see an add numbers object. I probably typed D1. D2 save add numbers dot obj 0600 to 0608. That did something, and now we should have add numbers obj. So there it is. It saved this file. I know this is all quite confusing, but at least you have this chapter to guide you, which is more than I had. Listen, when I was your age, this was hard. I had to figure this out by like typing in all the different possible commands. This guy's funny. He's like, this is hard, but yeah, it is hard. Writing programs that will run when loaded. That would be cool. You can use both the Atari DOS menu and the OSA Plus operating system to save machine language programs in such a way that they will automatically run as soon as they have been loaded into your computer's memory. When you select option K on the Atari DOS menu, your computer responds with this prompt: save, give file, start, end, init, run. I forget how to get back the menu. There's some way to, like, right now you can see I'm in this like DOS, like you just type stuff in thing. There's two ways to run DOS, either through a command menu or like this. And once you go this way, there's some way to go back, but I forget how to do it. So hopefully they'll tell us what to do. If you wish, you can respond to this prompt by typing only two addresses, start and end, but the prompt also allows you to use two more addresses, init and run. These two addresses are optional parameters. When you save a program without using these parameters, the program you save will load but not run when you retrieve it from a disk. To run a program that has been saved without using the init or run parameters, a special execute command must be run. Either option M, run at address on the Atari DOS menu, or certain special commands such as the G command that are available on various assemblers, debuggers, and operating systems. If you like, you can use Atari DOS to save an object program in such a way. Didn't we just read this sentence? Let's check. If you like, you can use Atari DOS to save an object code program in such a way that it will automatically run. I swear to... I think I just switched dimensions then, because like how I swear I just read that. Anyway, in fact, if you wish, you can even save an object code program in such a way that it will run as soon as a disk on which it is stored is booted. To flag an object code program so that it will automatically run when it's loaded in memory, you can save it from DOS using the init parameter, the run parameter, or both. The init and run parameters do slightly different things, so not surprisingly, they are used for slightly different purposes. Hello, just came across this channel by accident, lol. Hello, Costelina. That's a cute name. Oh, I don't have the YouTube chat in here. Sorry. Where are we? Right. When you use init, your program will start running at its init address as soon as that address is loaded into memory. When you use the run parameter, your program will start running at that address, but not until the entire program has been loaded into memory. So init is as soon as that address is available, and run when the whole program has run. Got it. So this is, init's probably some way to do like bootloaders or something, like, you know, that loading screen as it's still loading. Anyway. The init parameter is usually used for running short routines within a program while the program is being loaded. For example, converting text strings from one kind of a character code to another, so that the conversions will all be complete by the time the program runs. The run parameter is used to run the entire program after it has been loaded into memory. Using the run parameter, this is how you would store the add numbers object program with an Atari assembler editor cartridge. This is not what we have, so it doesn't matter. Where's ours? Where's ours? Let's just read it, I guess, in case, because I don't know where our instructions come in. This is how you would store the add numbers if you had the Atari assembler editor cartridge using the run parameter, but not the init parameter. ADD add numbers obj, comma 600, comma 608, comma 600. Notice the two commas between the numbers 0608 and 0600. In this example, they mean that the init instruction has been left blank and thus has not been used. If it had been used, it would be the third number typed right between the commas. Instead, the line number has been typed using this format. Add numbers, start, end, and then we skip it. We skip the init, run. The program will therefore run automatically beginning at address 600, the address entered under the run parameter, as soon as the entire program is loaded into memory. If you saved your program using this format and then loaded the program into your computer's memory, it would start loading at address 600 and would stop loading at address 0608. It would then start running at address 600. Oh, look, there's us. It's coming up real soon. All right. Using the init parameter. The init parameter of the Atari assembler binary, sorry, I'm gonna how do I hide this thing? Binary load command can be used either by itself or in conjunction with the run parameter. You can use the init command as many times as you like in a program for each portion of the program that you want to run as soon as it is being assembled. The run command may be used only once to run the entire program. Detailed instructions for using run and the init commands can be found in your Atari Disk Operating System 2 reference manual. I don't have that, but sure. For our purposes, all you really need to know right now is that you can save object code programs in such a way that they'll run after they are loaded by using the optional run parameter of the binary load command. All right, that was all good to know, but we're not using the Atari assembler cartridge. So this is what we're using, OSA Plus. Hopefully it's not too bad. OSA Plus doesn't provide any init or load parameters for running machine language programs because it doesn't require any. To run a machine language program using OSA Plus, all you have to do is use the run command. To use the OSA run command, just respond to the D1 prompt by typing the word run followed by the starting address of the program you want to run. Okay, so I guess I can do this. Oh, cool. Our program doesn't actually like print anything out, so we can't really know that it ran, right? So apparently it ran our program there. That's cool. Writing self-booting programs. Have you ever wanted to write a program that will boot itself and then run itself automatically as soon as you turn your computer on? Well, you can do that very easily if you know how to use assembly language. All you have to do is save the program using the auto run sys utility built into Atari DOS or the STARTUP.EXC utility provided by OSA Plus. Do we have those? Look, we have startup.exe just like they promised. That's right, because we're using OSA Plus, we don't have auto run, right? Yeah, we don't have auto run. So where are we? Use either of these utilities and your program will run automatically each time the disk it is saved. Each time the disk it is saved on is booted. Oh, okay, it was English. Will run automatically each time the disk it is saved on is booted. Just like a piece of professionally written software. We're almost professionals here. Two ways to do it. There are a number of ways to use Atari's auto-run sys. One way is simply to save your program as a self-booting program using the init program parameter. This is not us because we're not using the auto-run sys. Another way is to take a program that you've saved as an automatically running program and simply changing its name to autorun.sys. Here's how to change the name of a file to autorun.sys using the Atari Assembler Editor cartridge. First, make sure that the program you want to convert is already a self-running program. In other words, make sure that it was saved using either the run or init parameter or both, and then call up your DOS menu and type E for rename file. You should then see this prompt. Yeah, none of this really matters for us. Here's us using the OSA plus startup.exe utility. I'll call it XC. The startup.exe utility provided by OSA Plus is very similar to the autorun.sys offered by Atari DOS. To use the OSA Plus startup.exe utility, just boot OSA Plus, then replace your OSA Plus master disk with a data disk on which the object code of your add numbers program is stored. When your data disk is in place, respond to the OSA Plus D1 prompt by typing type E D1 startup X. This is the line you should then see on your screen. D1 type E D1 startup X. What's actually happening though? This is probably saying executable, type executable for this file, so we're changing this. Yeah, I don't really know. Let's hope it explains it. When you type this line, be sure to use the exact spacing that we use in these examples. In particular, make sure that there's a space between E colon and the D1 colon startup X. OSA Plus, like the Mac Assembler and the Atari Assembler Editor, is rather fussy about spacing. When you're sure you've typed a line correctly, hit your return key and your computer screen will go blank for a moment. When the lights come back on, you'll see a blank screen with a cursor in the upper left-hand corner. When the blank screen and cursor appear, simply type the word load followed by the name of the file that you want to convert into a self-booting file. For example, load add numbers obj. Next, type the word run followed by the address in hexadecimal notation at which the first instruction in your program is located. For example, run 0600. At this point, these two lines should be all you see on your screen. Yeah, the two we just typed. Now type return followed by Control 3, which is typed, of course, by pressing Control key and the 3 key simultaneously. When you've done that, your data disk should start to spin, and when it stops, addnumbers.obj should be stored on your disk as a self-booting file. When you've finished creating your STARTUP.EXC file, you can check to see if it's really on your disk by typing the command dir to get a disk directory. All right, so let's do all of this, but let's create a new floppy disk. So I need water first. How is everyone? There's some people here, right? Hello. Have you guys actually played with an Atari before? This is this series here. In case you didn't catch it, this is a series of videos. They're on YouTube. You can find them. We just read this book and we're learning Atari stuff, Atari assembly. Have you guys ever used Ataris before? The Atari home computers? Okay. Costalina, you're still here with saying no. Just relaxing, no Atari, no Atari. Okay, so this is all new for you guys too. I never messed with any kind of assembly. I only did assembly once in university where there was like part of a course for computer architecture. And we had to learn some assembly. I don't remember which one exactly, but that was the only time I did it. And I haven't touched it since. So, alright, so let's try. I'm going to put you on desktop mode here so you can see. I'm going to try to look at these disks here. This first disk here is the disk where we have our assembler. So I'm going to eject this. And it's going to say it's not saved. I don't want it to be saved because I wrote a file there by accident. And here is our roots stuff. We'll save this one. So let's do, how do I save? Save disk. There we go. So it's saved now. Now we're going to eject it. And to create a new disk, I think we press this like little arrow sign and we click new disk. And I'm just going to say single density, file system none. I don't know what this is. So let's put in a disk here. I feel like I should format it, no? Let's see if this works. Alright, so what happens when I run? Oh, 0 free sectors. I thought I did this before. Every time I do this thing, I always forget what I'm doing. Explore disk, swap, convert file system. Damn it. Single density. Unformatted. Maybe I need to pick one of these. Let's do this. All right, now what happens? All right, so at least we have sectors. I'm not really sure what's going to happen here, but we have a data disk now. And let's see if we can follow the instructions and see if we can actually save our program and turn it to a self-booting disk. All right, so what does it say? It says to type in type E colon. Do you guys hear the little like clicks that the Atari computer makes every time you type something? It's kind of funny, right? STARTUP.EXC. Make sure we type this in right. Oh, someone's telling me stuff. Damn, finding a disk creation utility sure as hell would have been handy in some of my retro computer emulation escapades. Yeah, right? Look how fast that was. It was like took a second to create, right? If I were you, I'd start small, say an STM32, write a bit of code, compile Flash, and debug. A beauty of a debugger is that you can show the assembly your C lines translate to. Atari is a bigger thing to get into if you're not experienced in firmware at all. Well, this is what we used to do, right? Like, my whole thing is I want to kind of know what it was like to be someone who was developing on these machines back in the day. Sort of like this nostalgia that I never knew. All right, so here we are. We did that. This is a line you should see on your screen. That is not what we saw, or maybe it was. It will go blank for a moment, and when the lights come back on, you'll see a blank screen. I think this is where we're at. When the blank screen and the cursor appear, simply type the word load followed by the name of the file that you want to convert. Oh, maybe I need to have this file in here already. Yeah, I bet it won't work. So I think I can do this also. Now type return followed by control 3. Let's hope that the control things work. Okay, so now we're back on D1. Now we type dir. Oops. Now we can type dir. We see startup.exe. Okay. Then if startup.exe is there, you can check to see if it works by turning your computer off, then turning it on again. If your computer is up and running again, load your debugger into memory. Yeah, and then you can use your D command to check memory registers. Let's try that. So I'm pressing Shift F5 in Altera. There is no DOS. Nothing is easy. I have to learn how to format a new DOS disk, right? That's what I need to do. I did sit through a course. Aton says I did sit through a course on programming it with C, taking full advantage of Antic GTIA's display list player missile graphics. That's so cool. I've heard about those things, but don't know. Do you know how to like, how do I make a new OSA Plus disk? I did make a little gist. Maybe I wrote down how to do that. Let's see. Atari cheat sheet. Bring it up over here. Here's general stuff. Make backups. Do not list. Yeah. Do not enable basic loading. That's what screwed us up earlier. This is where we got debug 65 from. This is, yeah, that's all stuff we know. New list, enter bsave, bload, ASM, CP, DDT. How to execute a program. No, we don't talk about how to make an OSA Plus disk. Although I think I downloaded the OSA Plus. I think I downloaded OSA Plus, maybe the book. Here's OSA Plus drive files. I could just copy the disk, like literally just do copy and paste, and I would have a copy of it. So I could do that. But I thought I had a book here that told me how to. Maybe it's this one. Let's see here. DOS.XL. Is this OSA Plus? Yeah, it says OSS Precision Software Tools. Wow, this is really hard to read. Um, if you know C, you'll understand these things very fast. You look at some H files and some examples. Cool. Yeah, I know C. I haven't done it in a long time. But here we have like duplicate disk, erase disk, basic. So this is probably with like the menu system, selecting menu options. But I'm not in the menu system anymore. Commands, intrinsic commands. There's probably something in here for format, no? Duplicate disk, menu. So let's do this again. Let's switch our disk to our original debugger and assembling disk. This is obviously a disk with DOS. Menu. Okay, so menu doesn't work. I'll have to find menu is on page 97. Here is the boot process. We learned a little bit about some of this, although startup.exe is in here. Assembly language and DOS, file structure, errors. Okay. Primary has two modes of command entry. You may choose either of a menu mode, that's what we're talking about, or a command processor. So another mode for DOS is a command processor or CP. Oh, that's what CP means. When I was in the assembler, I type CP and it brings me to the command processor. That's what that means. Right, so it says use the menu system if you want this. Command processor has these advantages. I just want to know how to switch between them. A lot of words here. Booting. First, you should know after fill out your license agreement. Right, of course, we're doing that. Single density, double density. Any case, okay, we don't care about any of these. Then a message will be welcome to DOSXL. The last line from the startup file is just menu. This is a command which instructs DOSXL to load the DOSXL menu. Wait, so how does that happen? Is it loading a file? Maybe I missed something. Connect your drive, turn on the peripherals, insert a DOSXL master disk. Okay, turn an Atari cartridge. Welcome to DOSXL. The last line from the startup file is just menu. This is a command which instructs Alright, so this is just like, it's in the file. I don't know how to edit files, so I guess I can't change that. Booting your system. We already saw this, right? The scrolling text which appears on the screen comes from a special file is named STARTUP.EXC. That's the one we were trying to work on. Selecting menu options. You should be presented with the menu option, right? But we're not here, right? Note if the version shows, yeah, none of those. Whenever you are prompted by enter file name, that's not us. Files on the Excel master disk. I don't know how to get back to the menu. Backing up your disk. We probably have to look for the command processor section. So we'll skip some of these menu things here. They're talking all about menu system. Entering the cartridge. We don't have a cartridge. It's talking more about the menu. For those of you who have previously used Atari DOS, here's a summary of the difference between Excel menu and Atari. Alright, we don't care about that. Entering commands. The menu is the following list of commands will show on the screen. Alright. Copy. So this is the command equivalent. So copy is, I can type copy in here probably. No, maybe not. Duplicate disk. Maybe that's what I need to do. Format destination, yes or no. Erase files. Allow delete files. Let's see if we can actually do this. So we have dir, right? Let's load another file. Here we will load the roots Atari file in D2. So now if I go to D2 and I look at this, I see these things. Let's see, it says erase is ERA. And then I'm guessing I can give it the file name. ERA foo.object. Yeah, so now foo.object is gone, and I can do ERA foo.source. Okay, cool. So that works. We're learning something about Atari DOS here. Directory, we learned that. Go to address, we know that. Initialize disk, maybe this is it. Allows you to format a blank diskette so that you may use them to store programs and data files. If you wish to create a bootable diskette rather than just a data diskette, you will normally want to duplicate your DOS XL master disk. In this case, you should use the duplicate disk command rather than the initialize disk command. If you want to duplicate any of your diskettes using the duplicate disk command, you do not need to format them first using the initialize disk command, for the duplicate disk utility will perform the format operation if you desire. Okay, so we've learned something. We should probably write this down in our cheat sheet, which is, where is it? Here. We will put it in here. Oh, am I not logged in? Oh, I am. Alright, so we'll put it on OSA. And we'll say erase delete file. To make a bootable disk, copy the DOS disk. Can use the duplicate CP command. And I think the duplicate CP command was, where was it? Up here somewhere. Copy files. It's not copy. Duplicate disk. It's called dup disk. I don't know what the second one is. Dup DBL? Maybe that means like double-sided. All right, let's just save that there. Oh, and then there's a init, which is like init to format a disk, but not necessary if you are duplicating. Okay, so that isn't the best notes, but it's better than nothing. So maybe we try this. Maybe we try to duplicate our disk. So let us, in here, we'll just make a new disk. Single-sided. We'll put it unformatted because we want to test that we know what we're doing here. And we'll call this like our AS. Oh, I can't call this anything. Why can't I name this any? Oh, probably when I save it, it'll name it. All right, so we have a disk in D2 now, right? So if I do dir on D2, it's like I can't see anything there. And in D1, I have my master DOS disk. Now I'm going to try to run duplicate disk, which is here. Here, let me go back into Atari mode here. And, oh, that's way too small for you guys. Yeah, that's not going to work. We'll just stay back in desktop for now. All right, so how do we run this? Of course, it's the page where it didn't scan right? Like, we can't actually see anything. Book, Negvorsa says, book written on a skin of dinosaur. This is legit. I can't even read this. CP equivalent dupe disk dupe double. This command allows you to copy quickly the entire contents of a disk. I don't know. Of a diskette to another diskette. If you wish to copy only one or just a few files from one diskette to another, or if you need to preserve some of the files, whatever, copy should be used. Copy files should be used instead. Yeah, we don't want to use copy. The duplicate disk command writes entirely new information to the destination diskette, thus erasing completely all files which previously existed there. Carefully select the desired destination diskette to avoid accidentally destroying your program disks. To select the duplicate disk command, type D. Yeah, but we don't have the menu format. I bet there is a version of this where they'll list what to type in for duplicate. No? Here's erase. Let's look for duplicate. Dir and erase load NOS? No screen. Turn off the screen. Wow. Protect. Rem. Rename. Run. Save. Screen. Causes batch. Okay. Type. Oh, this is what we used earlier. What does it mean? This command types an ASCII or a TASCII file to the screen. I see. It's a way to do an editor. It's like echo or something in Unix. Unprotect. What does extrinsic mean? Rename the file. C65 compiler. Clear disk. Config. copy files, do, dupe, here we go, dupe double. This program provides fast copying of entire double density diskettes. We have some info here. SAC 909, extrinsic equals external command loaded from disk. Intrinsic equals internal command in command processor memory. I love, how do you know this? Okay, I think I want to use dupe disk now, right? So, we're going to dupe the disk. This whole thing we're doing is basically so that we can make a bootable version of our assembly program. And it's funny that like learning assembly is actually the easier part. The hardest part is actually like knowing how to use the Atari. Like they just assume you know how to use like your disk drive and things, right? Like how to format a disk. Obviously, that makes sense. But I have zero idea. So that's actually what's tripping me up a lot more than the assembly language itself. Uh, Dom Cherry Holmes, probably one of the best experts on Atari 8-bit programming. I feel there was one game I played on the Atari that really amazed me. It was called Alternate Reality. And I was like, how did they get like an 8-bit 6502 to do all this stuff? It's crazy. And that's sort of like the fascination. Like, how do you have one accumulator, you have a few registers, like how do you do so much with that? Okay, let's see how this actually runs. Um, what do I say? Do I just say like D1, D2? Purpose, arguments, none. Doesn't take arguments. Doesn't it want to know where to run it, where to copy it to? All right, let's see. Well, that didn't work. Is that because is that just because I don't know why I don't have that. All right, we're just gonna have to cheese our way through this because since we're using an no, you know what I want to do is actually figure out how to bring back the menu mode for this OSA Plus. That's what's driving me crazy now because menu, this program provides a menu system. So I guess what happens is I don't actually have the menu version of this operating system. That's what this probably means. So maybe if I did this and use this drive instead, maybe this version. Here we go. Look at that. Now, no, 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 no. Oh my God, I did it by accident. I typed D by accident. Okay, so I think this is what I wanted. I have a real DOS. This is like a full DOS. And I pressed D by accident. But it's what I want. Duplicate disk. Double density. Sure. Source disk. I guess number 1. And I want to put it on my unformatted disk 2, right? So let's see here. Disk drives. New disk. This is my unformatted disk on drive 2, so I'll say 2. Format destination disk, of course. Put source disk in drive 1. Put destination disk in drive 2. When ready, hit return. God, I love this. For the extrinsic programs, right? That makes perfect sense now. So extrinsic means you actually will see the executables in the disk when you type dir, right? Like, so there will be something called menu. There will be something called double dupe disk or something like that. By the way, I love this like just like command line interface, like this driven stuff. Error. I don't understand. I have Guys, how did people survive in these days? I have the drive. Source disk, destination disk, format destination, yes. Go. Alright, it's not happy. Let's try again. Maybe what needs to happen is I need to save it as a single density. So let's try it again. Double density? No. Source is 1, destination is 2. Format disk destination, yes. Wow. So I wonder why it couldn't save as double density. Is that a setting on the drive? I don't think so. We see here, I'll put this window in the actual chat here so you can see. DOS-XL, aka OSA Plus version 2, is literally the Atari DOS2 file system with the menu ripped away and replaced with a command processor. What do you mean, oh boy, is that bad? Okay, thanks. You're gonna need a lot more of a crash course on Atari disk formats. Well, I'm hoping to just stick with this Atari Roots assembler thing. Isn't that good enough? Quit to DOS XL. So now I should be able to go to D2, and look, my D2 has all these files now, which is great, right? So which means I should be able to type menu here, and it brings me back. Alright, that's awesome. So now I have a copy of this thing under disk drives. I can probably save this now. So let's save this disk. Save disk, and we'll call it like we'll call it boot disk, boot ASM disk, because we want to try to make a bootable assembly program disk. All right. So this looks like it is in good shape. Yeah, oh boy, you're gonna need more. Yeah, floppy disks on old computers can be tricky to deal, as I figured out recently. All I wanted was to make a user disk for me to save my program in a game. Yeah. Oh, right, like, this is what I was doing before. How do do I call you T-Shack, or I'm not sure. But this is what I was doing before, and I felt like that was sort of like I'm not getting it, right? And right now, where we are in this book, Atari Roots, is trying to make us make our own bootable disk. So that's kind of where we're at. So what I will do now is look at our disk drives. I'm going to eject both of them. And on drive 1, I'm just going to put our boot ASM file. There we go. And now when I restart this, I have the full-on DOS thing. Now, what can I do? I think what we need to do is, I don't think we can make the, let's go back to our Atari Roots. So, oh boy. All right, so we have, we're trying to create this, but I think when we create this OSA STARTUP.EXC utility, I think we need to have the stuff in memory. So I probably need to load the assembler program, recompile, and then do this part. No, because type E D1, this is just going to make the thing happen. Oh, crap. Type E colon D1 startup.exe. So this is basically creating a startup.exe file. Oh, Chuck. Okay, got it. Here, let me put you in the screen, Chuck. You're like our guru. Okay. Oops. And we can make you a little wider. Right? Good enough, right? All right. So I think this is basically creating the startup.exe file, which is like I'm making a text editor, right? Put Max64 in D2, and what's actually is that it's using the E device as a console. Whatever is typed will have typed into the file, right? So if I do this, it's going to create a new screen, and then I hope it's overwriting the existing. Sorry, I'm trying to just move my window a little bit, but it's not being nice to me. Now we type D1 colon. No, that's not what we want to type in here. We want to type load add numbers, which is our object program, and run 0600. I see. So we need to just add the add numbers object file into this disk. That's what we need to do. And we know how to do that. That's exciting. Okay, now how do I end this? I think I just press enter again. No, control 3. All right, so now I have something called startup dot whatever it is. How do you scroll up on these things? Anyway, so if I restart this now, since it doesn't have the assembler, it won't run it, right? So let's load that up and actually save that object file into here. So here we can do this. We can do this. Da 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 da. All right, I just put it in D2. So here's D2. And I have add numbers obj here, so I think I can run copy. Is it cp add numbers.obj to D1 add numbers? I'm guessing here. Okay, there's a copy here, so I probably can do copy D2 add numbers obj to D1, which is where I am. Right? I just did copy. So now I have add numbers obj here. Right? So let us save this drive. Like I'm just gonna tell this guy that he can, oops, that he can save, because this is a good checkpoint now. And now I think I can restart the computer and it will run. Hey, it did it. So maybe I can run the bug 65 now. Oh, I don't think I have it in this. Oh, I do. And now I can display CB. And it has the result of our program, which is 4. So it ran our program because, yeah, because I did a hard reset. Type run. I did a shift F5 to do a, oops, why did that do that? I did a shift F5 to do a cold reset, but you're saying I can do run E477 to do a cold reset. Oh, that's cool. So something in that memory location basically is the command to reset. But this is a good thing to know. I'm going to add it to our cheat sheet. That's a good thing. Like, I know it's just like a drop in the bucket overall, but there's good things to remember. So cold restart is run E477, I believe. All right, cool. So that's really neat. And now if I switch this to my actual debugger, where's my debug disk? I have it in D2. I have bug 65. Ah, crap! Why does this keep happening when I am doing this? Enable enable basic. Probably because something is just wrong with, probably because this program is taking stuff from there. Okay. Well, we kind of proved that our program worked, right? So that's good. Let's continue then. Where are we? You can check if it's really on your disk by typing the command dir to get a disk directory. Yeah, we did all that. And we saw that we have startup.exe here that we wrote. And we have the add numbers.obj file. So that's really cool. But I can't really get bug 65 to show up for some reason. Maybe I should copy bug 65 to here. Like copy D2 bug 65. What is it, OBJ? Let's look. bug65.com. So I do copy D2 bug65.com to D1. Oh, it's already here. Then why does it crash when I try running it? 5 seconds free. Yeah, but like when I run the bug65 program here, oh, it has my program. Okay, now it worked. I don't know what changed, but you saw last time it was, it failed. Oh, it's not called CP? Why? Hello? We're good. Then you can use the debugger's D command to check memory address 600. That's what we just did, and CB, and yes. So that's what we have done. Calling machine language programs from BASIC. You can also run machine language programs by calling them from BASIC programs. Hey Chuck, like, so do you love Atari stuff still? Is it like you do a lot of different 8-bit stuff, or is it like mostly Atari specifically? Just curious. Calling machine language programs. But it's a complex process requiring an understanding of some fairly sophisticated programming techniques. So we're going to save our explanation of calling machine language programs from BASIC for Chapter 8, which will be completely dedicated to mixing assembly language and BASIC programs. Ah, okay, great. So now we're at the next chapter, um, which means we're kind of here. You can see we just finished chapter 5. Chuck, yes, I write software for more than 4 dozen retro computing platforms, including Atari 8-bit systems. That's so cool. So once you learn 6502 in general for one system, it's pretty easy to write it for another. And follow-up question, how much different is it to like write code for the, what's it called, Zlog, um, that like the Spectrum and all those run on? Is it like very similar? My goal is to learn assembly language. I'm probably like, if there was a progress bar, it's probably like 2% right now. So I guess after we've learned the general 6502, we've learned how to write a very simple assembly language program, running an assembly language program, and saving one, and making like making it bootable from disk. Assembler for different systems is often very different due to hardware architecture differences. Okay, yeah, makes sense. Like they might have different coprocessors and different registers. Because I write so much software for so many different systems, I typically write in C. That makes sense. And you probably don't write it on the act. You probably write it on a modern PC, which then like compiles it quickly, and you have an IDE and everything, and then sends it over to the destination machine to check. That's what I'm guessing. I wanted to actually program on the Atari because it just seems like what is the experience that people had. What? Oh, my picture's not showing up anymore. Hello. Makes no difference to me. Really? That's crazy. I want to try like getting a Zilog also just to see one day what that's like. All right, so anyone, I think we're gonna make a VOD out of this, but like that is really hard to follow. So I'll probably make a thing here where we just try to review what we've learned today in a less painful way. Let's see if we can actually succeed in doing that, right? So critical thing we've learned is DOS really matters. It's really important to have like your DOS disk that has all the commands you need. Otherwise, it won't be bootable. So just copy your master DOS disk, and then you can add your assembler program there, um, and um, and add your startup.exe, which we'll go over real quick right now. So I will go into desktop mode here. Okay. I am in the middle of making 2 major development playlists for the Commodore Amiga, how we used it as a scientific engineering workstation, and another playlist which shows how to make a game using the operating system routines, including the built-in multiplanar animation system. Whoa, that's so cool. How do I oh, I can go to your channel. Here we go, guys. Like, subscribe. This seems like a really cool channel. There we go. I will take a look at this. All right, now I know to look at that later. Do you stream also? So let me see if I can do this from scratch again. We are going to clear our disks. We can eject this disk and this disk. And I think this one has the assembler. Let's just check. Max 65. I think I can do everything from this Max 65. Thank you. No, I do not. I have to use my time very effectively as I am spearheading the FujiNet project. I'm a retro computing like noob. So hey, your website's a little slow. I think I've heard of it. It's like is a multi-peripheral emulator and Wi-Fi network device for vintage computers. The first completed hardware was for Atari 8-bit computers and development has begun for other systems. What sets FujiNet apart from other Wi-Fi devices is the new network device, the N device, or NDEV. The N device allows vintage computers that do not have enough processing power to handle TCP/IP connections to talk to modern internet over Wi-Fi. Virtual adapters have been created for many protocols. So basically, it has its own like processing power, and it exposes this as like a serial device or something like that, so that the Atari or any 8-bit computer can just doesn't have to handle packets and ordering and like lost packets and resending and all that kind of stuff. It sounds like that's pretty cool. What does it look like? Where's a picture of this thing? If you make it, you got to put a picture of it like right on the beginning, you know? Because we care about how things look. Or is it I mean, yeah, it has to be. It is exposed as a flotilla of serial devices for the Atari, including a fully featured network adapter. So wait. It's not going to the actual FujiNet. Here it is. Now I know what it looks like. That's cool. It's $80. FujiNet is the ultimate peripheral emulator. SIO, serial input output bus, and emulates devices such as disk drives, printers, and modems. It also provides, oh, that's so cool. So does that mean it can like, you can try to do a print, you can try to print to what it thinks is an Atari printer, but then it actually prints to like a modern printer, like AirPrint or something like that? That is so cool. It makes me want to get a real Atari. All right, things we learn. This is how we learn things. Okay. So let's go back to what I was doing before. Here is my master disk, and I am going to create a new disk here. Single density. This is how I copied it, right? Yeah, I did single density. Simulates printer simulates Atari printer, rasterizes it to PDF. Oh, that's so cool. And then you can like, yeah, you can get the PDF and then do whatever you want with it. Makes sense. So now we have a new disk in here, right, as D2. And now we should be able to run dupe disk. I think that's what we did, right? And then we say copy from D1, which is where we have our master DOS disk. We're going to put it in D2, and we are going to format. And then we say we're ready. And now in D2, we have a copy of D1, right? So that we did. And now we can name that something. Here, we'll kick out disk 1, and we'll save this disk. And we'll call this disk second time, because this is our second time trying this, but this time it's going to go smooth, right? So that's good. It's saved. I can exit this and put it in D1. Second time, here we go. So in D1, we have this is our second time disk. If I reboot it, it's a disk that actually works with DOS. I'm quitting to DOS here now. And now I can run my assembler, Max65, I assume. And then we can rapidly type in our program, which was, let's try to do it out of memory, right? So we need to tell it that it should place the stuff into memory after it's compiled. We have to give it like where it's going to start in memory, which is page 6 or object memory 600. Then I think after this, we probably add our label, add numbers, and we want to clear the decimal mode. This is something, Chuck, that I don't understand. What is this doing? Like, Atari basically has two ways of doing math, which is like binary mode, which seems like would make sense to do, and then it has like this decimal mode math, and we're I don't know. Anyway, so we're doing that, and then we're clearing the clear carry flag, and then we are how do we put something in the accumulator? Accumulator. It's not add with carry. Store. Damn it. We're close. Here, I guess we can cheat and look back up here. Store, add with carry, CLC, load. It's load accumulator. Load the accumulator with the value 2. That 2 is decimal, or maybe it's hex, I don't know. And then we add with carry number 2 also. Let's go crazy and add with carry number 3, just so that we can see the difference. And then after we add, we want to store it to memory location CB. And after we're done here, we want to, I think, return from subroutine. And then we want to end. Let's see if this actually compiles. We type ASM to compile. No, that wasn't good. Because I'm noticing it's putting it into memory at address 258, and that is not what we told it. So I must have screwed up the syntax here. I thought it was star equals 600. Maybe I typed in this thing wrong. Star equals, maybe it needs to be the $sign to say hexadecimal. All right, perfect. We figured it out. So this looks like the code is correct. I remember it ends in, the last instruction was 0, Yeah, thanks, Chuck. We just, yeah, got that. Um, so now we want to save this onto our local disk, and that is list, which was confusing for me at first, but it's like, is it $sign or is it just D1? Maybe it's $sign D1? I mean, hashed. That seems silly, right? Well, let's do it. D1 add, oh crap. List D1 add numbers dot source. Okay, so you got lucky. 200 to 500 are OS vectors and internal state addresses. Yeah, otherwise it would crash, right? Because it's actually putting it there. Um, it's kind of crazy how fragile that really is. And then I think I have bsave also, which will save the object code to the same thing. I think it's this format. No. No. Let's take a quick look at what I'm missing here. This was it. Enter. We did all that. We ran it. Yep, yep. Now we're saving. And this was, okay, so for this was in Atari DOS. And here is, right. We can do it in OSA directly. So we have it in memory already. So now I can exit to CP to go back to command processor. And I can do, I think there was a command for saving it, right? Where was it? I must have missed it here. Writing programs, save. Yeah, I think this is it. Here we go. It's just save, add numbers, .obj, and we give it the address where it starts and ends. And that saves it. We see the little light come on. Oh, you don't see the little light come on the drive. So now there is an add numbers obj file here that we see. And now what we do is we're going to create an auto run file. And we do that by doing type, which basically tells it to pipe our input into this file, STARTUP.EXC. I think Chuck, oh crap, it keeps deleting this. My understanding is that the E here is the keyboard, and it's saying like, hey, take stuff from the keyboard, maybe the screen, and put it into this file. So we do this. What? How come we don't have type? This did not happen last time. Did I type it in wrong? Oh, I must have typed something in wrong. And so the two lines that are important in here is load add numbers.obj and run 0600. And then I do control 3. That created that file. Yes, type it again. So let's see. You can save it here too. Typically the load and save commands are used for a final load when assembling a very large program that has to be assembled in chunks. That makes sense. I was wondering, because otherwise, why don't you just like deal with the source code? Okay, so now we have our startup.exe file, and I think all I need to do now is just do a cold restart. And we've learned that 477 will do a cold restart. And we have run our program. You see it automatically did that. And now I can run the debugger, which is bug 65. I don't know why it does that. And then I ran it again and it was fine. So weird. So display CB, it has the number 5, which was what we were adding together, right? 2 and 3. And we can see our code in 600. This is our assembly code where we are telling it to do stuff. Here is the load accumulator with the number 2, A902. And here is add with carry with the number 3. And here is store accumulator into address CB. So it worked. So example, you can add an org at the bottom to address 02E0 with word 0600 to automatically load your program. Ah, really? I don't understand that, but I think it's okay. Well, that was the review of what we learned today. Thank you so much, Chuck, for helping us as our guru. Thank you so much for working on FujiNet. I think one day I will actually make use of it. Yeah, and we're just slowly going through this Atari Roots book. It seemed like most systems basically, sorry, without needing to run. Oh, okay. All right, I'll check that out. Seems like most books where you kind of have to like learn the 6502 and then learn particularities for the platform you're building, but this book actually goes over kind of how to do it all at once, which probably means it's not the best 6502 book nor the best Atari book, but for someone like me who doesn't know either, it's pretty useful. So thanks for tuning in. Do like and subscribe if that suits you. And do follow Chuck also. I'll put a link in the VOD when we make it. So thanks so much. Take care, everyone. Bye.